Dr. Colleen Naughton, who is an assistant professor in civil and environmental engineering at the University of California, Merced. Professor Naughton helped to lead the hashtag AESPTeach and the crowdsourcing of virtual teaching resources on a Google Sheet and on the AESP website during the transition to online learning with the pandemic. Dr. Naughton's research focuses on designing sustainable and culturally sensitive food, energy, water systems. She recently received 2 COVID-19 emergency seed grants to conduct a microbial risk assessment of SARS-CoV-2 in wastewater for vulnerable populations, and to study adaptation of the food supply chain to the COVID-19 induced shock. Dr. Naughton has also published a perspective piece on COVID-19 impacts on waste management. Dr. Naughton received a BS in civil engineering with environmental concentration from Purdue University and an MS and PhD in civil engineering from the University of South Florida with a certificate in water health and sustainability. Professor Naughton is also our conference co-chair and a co-PI on the grant that made this conference possible. So please welcome Dr. Naughton to talk to us about what happens when you flush the toilet.
Hello, everyone, and thank you, Dr. Stewart, for that introduction. I'm honored to present to you today about what happens when you flush the toilet. As mentioned, this was part of a seed grant funded by Citrus, and it's a team effort, and I'm honored to present on behalf of my team, many of who are on this call today. Next slide, please. So many of you may be in civil and environmental engineering and know about wastewater treatment, but please bear with me. I know there's some that do not. And before I get started about what happens when you flush the toilet, in accordance with the theme of equity, not everyone in the world and even in the United States have access to wastewater treatment or sanitation or toilets. Billions in the world do not have access. But for those of you that are lucky to have access and running water, it starts with flushing your toilet. You may have a squat toilet and not a seated toilet. And then it goes down a pipe and into your piping system in your house in number 2, and then goes out to a sewer line or into a septic tank. And hopefully you're only flushing the 3 Ps, poos, pee, and paper. And it can travel for miles to a wastewater treatment plant in number 3. Like in Los Angeles, it's a very large wastewater treatment plant. And then it goes through many steps to be treated to protect public health against diseases such as SARS-CoV-2 and other pathogens. And so it goes through chemical, physical, and biological treatment, and even disinfection with UV or chlorination before it's discharged into the environment and meets regulations such as in the ocean in LA or in other places that might be a river or a creek. Next slide. In the context of COVID-19, we've seen wastewater being used as a public health tool to inform decisions and actions through wastewater-based epidemiology. So up to over 50% of people shed SARS-CoV-2 in their feces, whether they're symptomatic or asymptomatic. And then civil and environmental engineers or scientists can collect it through the sewer system or at wastewater treatment plants. And they can sample large populations through one sample, like wastewater treatment facilities serve hundreds, thousands of people, and you can filter the sample and quantify the virus over time. There are, of course, difficulties in this process, and it should not replace regular testing. Next, please. This is not a new technique, even if the news might feel it is. It's been used for decades. It's been used for poliovirus and for opioid detection. Next. And it's being used globally since the beginning of the pandemic all over the world to detect SARS-CoV-2 in the wastewater. Next slide, please. So this is your quiz question if you're taking the quiz, so please listen if you haven't before. So SARS-CoV-2 can be used in wastewater testing, can be used as an early warning system. It's faster to process samples for larger populations. People that are asymptomatic are shedding it. And people at the early stages of the infection before they're tested may be shedding it. So it can be anywhere from 3 to 14 days before shedding. And this is an example from Yale University, and they have a great website. Next. You might have heard University of Arizona used wastewater to detect an outbreak before it started. And next. And cities, Ottawa, there's been a lot of talk on Twitter about the increasing concentrations in Ottawa's sewer. So it can be used as for individuals. They see concentrations increasing. They know they need to physical distance more, use masks. Public health departments, states, cities, and countries are using this to implement measures, maybe even shut down schools or bars or restaurants to kind of stop the spread before it gets worse. Next slide. And so this is combining my two loves, the wastewater and mapping. There's a lot of dashboards available now, not in every state, but Utah has an decreasing present stoplight approach. And you can click on there to see the concentrations. So increasing is red, decreasing is green. Ohio is the CDC and EPA pilot site, and they have tons of places they're monitoring throughout the state. And a lot of websites just show the concentrations over time. This one's showing with our third surge that we're seeing in the United States. We're seeing that in wastewater as well, like in Massachusetts. And Tempe, Arizona also has a great dashboard as well. Next. So our group is trying to foster informed decisions and actions by putting this all in one place. We were inspired by the Johns Hopkins University dashboard. We wanted to make a similar one for wastewater, their dashboards on COVID-19 cases. So you can zoom in on areas of the map, see if wastewater testing is happening in your area, visit the different websites and dashboards. And this is part of a larger COVID-19 wastewater-based epidemiology collaborative. The website's on the bottom right. And we also have a Twitter account at COVIDPoops19 if you want to follow that and learn more about SARS-CoV-2 and wastewater. So thank you for your time, and I look forward to questions.